Hello everybody, Mr. Keeney here again. We are moving on a little bit in our Unit 2. This is our angle relationships and logic unit, and we've been talking a lot about deductive reasoning and logical arguments, specifically conditional statements as of lately, but in these notes we're going to be talking a little bit more about algebra. We're going to be solving algebraic equations. We're going to do this using two-column proofs. So really what we're going to go out here is we're going to solve these equations, but we're going to solve them and then justify each step as we go. Before we go ahead and do that, I want to remind you on some algebraic properties. So this whole section, in this section, I think there's 2 days of it. It's about using properties that we learned from algebra. So a little review. If we know that we have A, B, and C, and they're real numbers, and we have an equation, it says if A equals B, then the addition property says I can add the same thing to both sides of the equation and still get an equation. Meaning, if I were to add C to the left side, I can do that as long as I add C to the right side. So if A equals B, then I know that A plus C equals B plus C. But we can also do this for the subtraction property, the multiplication property, the division property. We just do that operation that they're wanting us to. So for example, if A equals B, the subtraction property says, well, I know that I can subtract C from both sides. As long as I'm subtracting the same thing from both sides, I'm still going to get an equation. Same with the multiplication. If I multiply, so A times C, that will be equal to B times C if I know that A is equal to B. Division property, and you can kind of see where I'm going here. We can divide things on both sides. And we do this a lot to solve equations, which we're going to do here in a second. Our last one, substitution. This one is a little bit different. If A equals B, then what we're going to say is B can be substituted in for A. And we do that whenever we find something that x is equal to, we find its value, its missing value, and then we plug it back in maybe to find a segment length or an angle length, a lot of things we did in Unit 1. So now we're getting to the main thing here. Example 1, and this is kind of your first proof in this class here. We are going to solve the equation 2x plus 3 equals 9, and we're going to write an equation for each step. And we're going to always start off these proofs with just what they give us, 2x plus 3 equals 9. Now, this is our first step, and we're going to give a reason for this first step. Why did we know to put that down first? Well, that was our given information. We're always going to start with saying given. In geometry, they give us information. We will start with that, and we will use our math skills to work from there. Now for my second step, what I'm going to do is I'm going to get this statement, and hopefully you guys can pause the video maybe and try to figure out how did he do this? What would justify him saying 2x equals 6? So go ahead and pause. And if you've unpaused now, hopefully you came up with what I did was I used the subtraction property. Subtraction property says that if I take away the same thing from both sides, so what I did is I subtracted 3 from both sides. The 3's canceled on the left, and 9 minus 3 is 6. So we're going to say subtraction POE. If you're wondering what does POE mean, I'm going to highlight it up here. Property of equality. So we're going to always put subtraction and then POE. Statement number 3 is actually our last one because I'm trying to solve for x, and I get x equals 3. Go ahead and pause right now, try to figure out how did I get x equals 3. And if you are back, hopefully you realize, oh, he divided by 2 on both sides, and the dividing by 2 on both sides is justified by the division property of equality. So there is kind of your first algebraic proof. We're going to do another one here. This one's a little bit longer, it looks like, but no worries whatsoever, we can do it. So we're going to start off with just getting down our equation. Equation is 3x plus 8 is equal to negative 6x minus 34 plus 2x. Our reason, like always, is this is our given information. We will always start off with our given information. I'm going to go ahead and change colors just to make it not too hard on the eyes here because I have this negative 6x and 2x. So if I were to do negative 6x plus 2x, I get negative 4x. So here's what my next statement looks like. 3x plus 8, nothing over there, equals negative 6x plus 2x is negative 4x and then minus 34. Now, I know some of you might be thinking, okay, you added those together, Mr. Keeney, but remember the the addition property says I have to add the same thing to both sides, adding c to both sides. And in this case, I did not add the same thing to both sides. All I did was take the two like terms and I added them together. So our reason for this, and you've heard this, I'm sure, before in your algebra class, is combine like terms. I combine like terms, negative 6x and 2x together. Now for my next step, step number 3, what I am going to write down is 7x plus 8 equals negative 34. Again, go ahead and take a second if you need to. How did I do that? What I did was I added 4x on both sides. See, now this one is the addition property. The addition property of equality says I can add the same thing on both sides. And what I did is I took this negative 4x and I canceled it out by adding 4x to that, and I added 4x to the other side of the equation. For my step number 4, oops, that is not what I wanted to write with. For my step number 4, I have 7x equals negative 42. And for step number 4, again, hopefully you're trying to figure out this as well. This would be the subtraction property of equality. I know this because I subtracted 8 from both sides. Subtract 8 just to leave me with 7x on the left side, and then negative 34 minus 8 is negative 42. And my final step for this one is that x equals negative 6. And I did that because I divided by 7 on both sides. So I was using my reason is the division property of equality. And we are done. So there's your second one. So we have 2 there. So we have your first one, your second one, using these properties up here. I'm going to introduce you to one more that I know you've heard of before. It's the distributive property. Distributive property, if we have A times the quantity B plus C, what we do is we can distribute this A in here and multiply. So A times the quantity B plus C is equal to AB plus AC, where A, B, and C are real numbers. So we're going to use that here, and we're going to do our last equation of the day, solve, and I'm going to go ahead and write it down as I say it. For our step number 1, negative 4 times quantity 6x plus 2 equals 64. Our reason, given. Again, for a third time, and it's not going to change. You start off with your given information. Your reason is given. So going to step 2 here. I'm going to go ahead and use this newly found distributive property and distribute that negative 4 in to get negative 24x minus 8 equals 64. My reason, like I just said, was the distributive property. I'm going to say distributive prop. You can see up here, distributive prop, just kind of shortening up that property there. My statement number 3, I have negative 24x, and I'm going to add 8 to both sides. Kind of gives away what I'm going to say here. Add 8 to both sides to get 72. So if I'm adding the same thing to both sides, that would be the addition property of equality. And then my last step, x equals negative 3 after I divide both sides by negative 24. So I am using the division property to do that. I'm dividing on both sides. That is, and yes, I was checking, that is our last example. So there is your 2.5 day 1. There's some practice for you guys to try as well. Your first proofs in this class, and they're algebraic. So hopefully a little bit of comfortable and things you remember doing. So have a great day, and I'll talk to you guys later.